excited to listen to you guys.
Thank you, Daniel. Hi, everyone. By the way, are we recording this?
Yes, we're recording this.
Where's the camera?
Should be over there.
Oh, hi, Mom. Look, I'm wearing the tie you made me. I'm on TV. All right, so thank you, everyone, for attending. I must say, I especially appreciate the fact that you're here, not in the main keynote hall. In the main keynote hall, you find my colleague George, who's talking about kind of normal Java stuff, which, as we know, is boring. Happens to be one of my responsibilities, but it's boring compared to what we do here. And in case we need to convince you to be here rather than there, this is the place where we bribe you with Raspberry Pis. So I know we kind of had to give you a little gift to entice you to come here, but, well, thanks for being here anyway. I'm going to assume it's all for me and not for the Raspberry Pis. All right. I'm sure some of you know me, maybe not all. My name is Henrik. I've been here at JFocus before. I'm Swedish, but I live in the US these days. And I'm responsible for product strategy for Java at Oracle. So everything except Java EE. And one of the things that I've been working on the last couple of years is trying to figure out kind of what are the new places where we can take Java, where Java makes sense, and what are new things that we can do. And of course, part of this is what makes sense for Oracle. So we make a big investment in Java, and somewhere we need to recoup that investment because we're not charging you money for installing Java on your desktops. Thank God. And one area which is really exciting is this kind of third wave in internet development, and that is what we're going to talk about today. So never mind the name of the talk here. It was made up by my esteemed colleague here. And never mind the kind of very detailed disclaimer you have to read before I can tell you anything. And there we go. If you didn't have time to read that, sorry. All right. So what are we going to talk about? Well, it depends a little bit on whether you're a business person or whether you're a developer. So I'm going to ask up front. So I assume there are only two types of people in here, either business people or developers. So if you're a developer, hands up. Wow, I'm in the wrong room. If you're a business person, thank you. There are a few of us around here. All right, very good. So this will be a little bit business focused, but I'm a developer myself, so I tend to be a little bit pragmatic about things. Business is good because it helps us pay us to do fun things, basically. The good news about this entire area is it's actually a huge amount of business in it for us, which is great, right? Because someone will pay us salaries. But it's also fun because it's not stale web application development. I'm sure all of you have done web application development. I've certainly done my share, and I know how to do it, right? There's not much news in this. I mean, not even mobile application development is all that much fun anymore. You know how to do it, and I'm sure some of you will do it. This is a new area, so it's an opportunity to learn new things. And it's also an area which will be growing extremely rapidly. So it's kind of a good place to go into if you want to start your own company and make $1 million. And by the way, I have a great make money fast story, but I'm not going to tell you here. So if you want to come and talk to me, either after this talk or elsewhere in this conference, I'll tell you how to make $1 million in a year. Okay? Guaranteed. All right, very good. So what's happening in the world? Why we have these three waves. All right. So in the 1990s, approximately speaking, you started to really see computers become connected. Early 1990s, you still had modems, but increasingly it wasn't bulletin boards, it was actually internet. So people were connecting to the internet over their modems. Well, over time, they moved to phones. So if the 1990s were kind of the internet of computers, the 2000s were more the internet of people. And as you move on to the 2010s and moving forward, we're kind of moving into the internet of things. So people are now connected, and now it's time for things to become connected. And this is not the 1984 or anything like that you may fear. It's just about normal things that make your everyday life easier, becoming connected. Now, an interesting thing about things is that there can be a lot of them. If you look at the total market for phones in the world, it's not realistic to assume that there will be more than on the order of 1 or 2 phones per person in the world. So there's like a market cap of maybe 10 billion devices. It's a good number, don't get me wrong, but it's still a market cap of, at the absolute max, 10 billion devices. Probably a few less than that. All right, so for devices, that is not true. There is no real cap. You can have devices anywhere and everywhere. You can have a device in every light bulb in your house. As a matter of fact, you can buy light bulbs today that have a small microcontroller in them. You can have a device in every street lamp. You can have a device, of course, in your car. Probably not one, more like 200. All right, so the whole bunch of these around, and all of them will be collecting data, right? And you have to manage and process that data. And some of them will be controlling something. Maybe it's your coffee machine. There's a great video on the web on someone using a Raspberry Pi to control a coffee machine. You can find it on YouTube. It's kind of fun. The point here is that it'll be a huge amount of these things, and they all have to be programmed. They all have to be managed. We have to get the security in place. We have to figure out how to do software distribution, because the little thing here, I'm borrowing one of my friends here, this thing may cost, I don't know, $2 maybe, whatever, but installing it is really expensive. So you don't want to go and have to reinstall it all the time. So you have to remotely be able to manage and update these things. And you cannot predict when you put it in place what type of software you will have to run on it 10 or 20 years down the line. Maybe the standards have evolved, right? Maybe there's a new regulation in place. How do you handle that? These are really interesting challenges. And of course, dealing with the massive amounts of data is another piece of challenge. This is not a particular industry. This is like across the entire spectrum of industry segments that we have. Some of them are early adopters for various reasons. Maybe it's very efficient for them to be early adopters. Maybe they can make money off it very quickly, or at least recoup the investment. But it's really across the entire spectrum. Some of these segments are more complicated than others. Some have been out quite early. Like, for instance, energy has been very early in Sweden. Most of the companies in Sweden have smart meters. Well, let me share something with you. Smart meters that are deployed are not very smart. They're actually pretty stupid. All they do is collect information and then send it to a back end, which is great, but there's no two-way control most of the time. You can't reprogram them to kind of select when they should and should not turn on and off energy in your house, depending on the price of the energy, and so on and so forth. So there's a lot to do to make things smarter. Let me take one very specific example, which is fun, if my computer would like to move forward here. Hello. There we go. I want a clicker. I don't have an Internet of Things clicker. All right, does anyone remember about 10, 15 years ago, so late 1990s, early 2000s, there was a lot of talk about smart homes and about all the great things we would do with smart homes. And there were a whole bunch of companies that were starting out efforts around, like, how would you handle security in a smart home and blah, blah. And it all came to nothing. I think one of the reasons why it came to nothing was some of the ideas were a bit kind of out on the edge, like, why would I want my refrigerator to tell me what I want to buy for food? I think that's a pretty stupid idea, right? And I don't want my house to be smarter than I am. I mean, I can be pretty stupid, but I certainly don't want my house to be smarter than I am. Another problem was technology wasn't mature. It was too expensive. It was too hard. It was like too out on the edge. But I read somewhere that you should never overestimate the impact of technology in the short run. But you should never underestimate the impact of technology in the long run. I think that's very wise. So it took a while for e-commerce to take off, as a number of companies in the late 90s, early 2000s found out to their chagrin. But today, everyone is buying things from the Amazons of the world, right? So smart homes, it will certainly be something that everyone has at some point in the future. And it won't be particularly smart. It will just be there to serve you. It will do very, very simple, basic things like making sure that when you walk out of a room and no one's in the room anymore, turn down the lighting a little bit to save energy, right? security system, home alarm. Why shouldn't it be easy to access my security cams from my phone? Or if I'm leaving work to go home, 20 minutes before I get home, kind of raise the energy a little bit. Maybe make me a cup of coffee, right? These things are not hard, but these are the things that will make the smart home succeed. Not the complicated things, not the nice kind of heads-up display on the refrigerator, but actually the everyday small things that make life a little bit easier and save you a little bit of money. And this is possible now. It wasn't 10 years ago because it's too expensive. Today it's possible because it's cheap and simple. And there are innovations that are making it cheap and simple. We're going to hear about Java in this talk, and we're going to hear about some types of hardware that make it cheaper and simple as well. I almost wish we had an operator here today, because they've also done a lot of things to make it cheap and simple. Anyway, so it looks great, doesn't it? I would love to have a house like this that does all these things for me, of course, when I ask for it. But behind the covers, there are a number of things that need to be in place. Right? So I'm saying cheap and simple. It's true, it's cheap and simple for the end user, but someone still has to build the solution. And building the solution is still a little bit too complicated. Not too complicated, mind you. Any one of you in here, you're a developer, you can do this with a little bit of work. I take a little Raspberry Pi. I actually, what I'm going to use one for, they haven't given me one here today. I guess they don't give them to speakers. I had to buy one. But given they cost like $35, I don't think it will break me. What I intend to use this for is I'm going to buy a couple of magnetic valves, and I'm going to use it to control my irrigation system in my house. Because I think it's really, really boring to go and turn on the water when I want to water my lawn. But it's very trivial to program this with a rain sensor and a timer, so I can turn it on appropriately. You can buy something that does that for you for like 4,000 Swedish crowns or about $800. But why would I do that when I can build it myself for $100, right? Or maybe even less. Besides, it's more fun, right? Anyway, so you guys are going to be building solutions like this. You're going to build software for this. You may be working for companies that build hardware solutions for this, and the prices of these things are going to come down dramatically. Right? But that has to happen some way, and it has to happen because you have to make building software, maintaining that software cheap, simple, easy, and we have to solve some very fundamental problems like security. And there are some really complicated problems to solve here. For instance, this is kind of an architecture of a smart home, right? You have a gateway, which is your entrance to the world, and you have a bunch of small edge devices that do different things. Now, the gateway is a little bit of a unique piece of component. You probably don't want more than one of those because it's a waste, right? That's kind of where your broadband provider plugs you in, and it's also the kind of the right place to act as a control mechanism for your house. So the challenge with that gateway is you may have an application running on it which collects information about your utilities, your water and electricity. You may have another application which talks to your home alarm system, right? Or something that talks to an insulin sensor if you're diabetic. And you certainly don't want information about your insulin level to go to your utilities company. Okay? And you certainly don't want your neighbor to be able to turn off your power in case he thinks your stereo is too high. Right? That would be pretty bad. So there are some very basic problems that have to be solved here that are very hard. Luckily, that's kind of where vendors such as Oracle come in. We provide infrastructure components to help solve those issues, and which means you can focus on building the services, and the services is where the value is, and that's what people are prepared to pay for. All right, it's also the fun part. So, current challenges today, well, the entire embedded industry is very, very proprietary. So it's kind of, when I look at the state of the hardware and software platforms, it's kind of where the PC market was in the mid-80s. So it's almost 20 years old. That may be a bit unfair, but it's reasonably apt comparison. You have, I don't know, 10, 15 different common hardware architectures spanning from 8-bit to 64-bit. You have, I don't know how many operating systems. Some are small shims, real-time OSs, large Linux, Windows, Android, whatever, you name it. It's very fragmented. There are no standards. It's not like a PC where there's like a reasonable standard for how hardware works. Like there's no standard for how these things works. Or actually there are lots of standards, which makes things even worse because everyone kind of has their own. So that's a problem. Fragmentation in hardware. The number of embedded developers across the world, the people that actually know how to write software for embedded systems, according to ARM, is on the order of 200,000 to 300,000 people. I don't know if that's true. It sounds a bit low to me. But if we're talking 50 billion devices like some analysts say, other analysts say 1 trillion, by the way, so I don't know what to say, but it's certainly going to be lots, right? Where are we going to find the developers to build software for these things? We certainly won't be able to take these 200,000 developers and clone them 20 times over, right? So that's a problem. How do you find the developers? And another very interesting challenge that the telcos have been kind of having big concerns about for a long period of time is network bandwidth. So 50 billion devices sounds great, but how the heck are you going to make sure that they don't completely overload the network? Especially since a lot of the traffic that gets sent over the network is extremely low quality. Like, I'm not very interested in knowing that my temperature in my house in Stockholm is 20 degrees. And it was 20 degrees 2 minutes ago, and it was 20 degrees 4 minutes ago. I don't care. I want to know if it changes. Well, if you have a current smart sensor, they're not very smart, remember? They will actually send you that reading every 2 minutes or every 30 seconds or every whatever. And that data is extremely low quality. You don't want it. You just want to know when something changes. All right. So the question we ask ourselves when we look at this is, we've managed to kind of solve these problems. So never mind the Oracle logo on the left-hand side here, right-hand side. We kind of managed to solve this in the industry together over the last 15 years on the server side. Like today, there are a few major operating systems. They all have very similar capabilities. We have some very basic standards. We have things like Java, which clearly is the dominant runtime on server side. You have Java EE, which pretty much a container that everyone uses with a few notable exceptions. You have some basic software components that get reused time and again. SQL database is one example. New things pop up from time to time to meet the demands on new use cases. But even so, the number of kind of high-level components that you have when you want to build a solution are fairly limited and fairly well understood, right? Which makes you guys very efficient. So that's good. Efficiency is good. Of course, it's also a little bit boring, which is why you want to do something new. So how can we take the lessons learned from the back end and move it to the edge? That's kind of that's the direction that we're taking from an Oracle perspective. When we talk to companies that are more in the traditional embedded space, what they're saying is, how can we take the knowledge we have and make it simpler and easier? So how can we make that meet the simplicity that has been created in the server side, as well as in kind of desktop mobile clients? All right. Well, we look at this space. Was kind of right after the Sun acquisition. I was part of the team that was analyzing the IP that came in from Sun, and figure out, like, how can we use this? Well, clearly, there's no point in trying to build another smartphone platform. There are a few out there. I mean, more power to them. Let them continue to exist. But there are places where something like Java can really help make a difference. So one of the really nice things about Java, well, it is standards-based, at least to the extent that if you code to Java, you know what you're getting, you know where it's going to be 2 years, 10 years from now. The standards evolve, to be sure. You can help influence them. Yes, it's controlled. It's led by Oracle, right? But it's still a quite open ecosystem, and there are good ways to influence it. No one will do anything from behind your back. So it's very predictable, which is nice. We have a huge developer base. Huge, right? I mean, there are at least, 100 people in this room? Okay. Overall, give or take 10 million people. 9, I guess, is the Oracle official term, right, in Java. If I can enable you to easily take your skills and move them to this space, not only will there be a lot of developers that can help build software for these 50 billion devices, but your careers are guaranteed for the next 20 years, at least 30, whatever. Big number. Java is very mature. As a matter of fact, you may think that bringing Java to these small devices is new. It's not. Clearly, Java has existed on feature phones for a long time, but Sun and other vendors also had Java available for embedded systems. They weren't talking a lot about it, relatively speaking, but the technology is there. It's being used all over the place, and a lot of people know how to do it. The technology stack is quite mature, so we're not really inventing something new. We're just taking something that exists and making it more broadly available. So let me ask one question here now, since I don't want you to fall asleep. How many has a Blu-ray player? Come on. Blu-ray players, anyone? All right. Are you aware of the fact that every Blu-ray player in the world runs Java? It does. It's part of the specification. Just take one example, right? So, good runtime environment, great development tools, standards-based, lots of developers. There's a really mature ISV and developer ecosystem around Java, so it's very easy to take existing components and repurpose them. Maybe you have to rewrite them a little bit to make them smaller, right? But network stacks, security protocols, data integration protocols, management, all these components exist in one form or another and can be repurposed with relative ease. Okay, I was at a technology conference with Freescale in Austin, Texas, about 6 months back, and they had a panel with a number of kind of industry luminaries, and they were like talking about how on earth would they solve the multi-core problem. So their microcontrollers are moving from 16-bit to 32 bits, which is a huge problem for them, because now they have to go and recompile all their code, and they're also becoming dual core. Okay, and their operating systems and their applications are not thread safe. So they have a huge legacy of software that will break. And I kind of was like, have you thought about using Java? I was like, yeah, we heard about Java, but it was kind of big. Well, it's kind of small. You can run it in 8K RAM. Really? Yes, well, you can. Not SE, but ME. Oh, that's cool. So what support do you have for multi-core? Well, we have threads. You have threads? Wow. Yeah, and we kind of have lightweight synchronization primitives, and we're working on closures, and oh, does that work on my microcontroller? Yeah, it's like just works. Just take the code and port it. It just works. They couldn't grok. They could not understand that it was that easy. Okay, and for you guys, this is trivial. This is ridiculous. Of course, everyone knows how to do synchronized in Java, but if you're an embedded developer working on a microcontroller, chances are you never even thought about it. Okay. All right, so lots of good reasons to do Java. So that's technical reasons. What about business reasons? So this is where everyone except the business guy that kind of put up their hand at the back of the room can shut their ears and fall asleep for a while. There are good things about Java. One is you can extend the product lifecycle. What do we mean with this? Well, I met a vendor at ARM TechCon in the US. They sell vending machines, and they have 4 different hardware architectures and 6 different operating systems that they have to maintain. And every time someone does a hardware revision, maybe they can't buy a particular chip anymore, they have to make a new hardware revision, they have to report all their software to the new vending machine. So the idea of being able to write the application software in Java and reuse that between generations is hugely beneficial to them. Another example is if you have, as I'm sure you'll hear more about in the Gemalto talk, if you have a piece of hardware that requires some sort of certification, right? Maybe you need to get it certified by FCC in the US, or whatever the name of that organization is in Europe, right? So for radio certification, every time you change anything, you have to recertify it. Right? You certainly don't want to do that just because you fix a bug in your software. That would be really expensive. So if you can separate the application layer from the system layer, okay, and not touch the system layer, then you can rev the application at any frequency you want, install new features, capabilities, and you can roll it out in a matter of days or weeks rather than months. So clearly, that's a huge business benefit. You benefit from the existing very rapid innovation in the Java ecosystem. Well, I know some people think JCP is not very rapid, but you should go and look at radio standards. Like, that's slow, people. And of course, you get a huge market reach. Like every system integrator in the world has huge sets of developers that know how to do Java. If you do Java on your embedded devices, you will get them automatically. I talked to the lead of some of the large practices at Accenture right before Java 1 last year, and they have a huge problem in this space. They have, if you combine the people that know anything about Oracle and people that know anything about Java and people that know anything about kind of mobile development, that's like, I don't know, 70,000 people or something within Accenture. Let's say they don't do Internet of Things development because they have to have like 4 different developer teams, one doing the back end, and there's some other language on the front end, and there are like 2 or 3 gateways that have like different specialized technologies. It's too expensive. Like they don't find a good way to spread the cost. They can't create a blueprint they can replicate because things change too rapidly. So there's huge barriers of adoption for spreading this technology. And you help reduce cost, of course. Shorter time to market, standards-based, blah, blah, blah. All these good things. Java's great, people. Did you ever think about how good Java is? I also like the coffee. All right. So what's our vision for this? Well, it's very simple. We want to make Java the #1 platform for embedded. Some people don't like the term embedded. We happen to use it because, well, it's the one we've been using for Java for a long time. You can equally well replace it with something like Internet of Things, or you can say machine to machine, although in my view that's a little bit of a sub-segment of the Internet of Things. Some people say Internet of Everything. We call our strategy device to data center. Pick your poison. It really doesn't matter. Small things connected to backends. That's the point. And if we can make Java work across the board on all these devices, we'll make life a lot easier for you guys, and you can build some really cool applications and make $1 million or more. Okay? All right. So, unified development experience, common runtime, common tooling, common management, common security across all these tiers. Sounds almost too good to be true. Well, it's not, as a matter of fact. So, if you look at technology, this is technology available today. You can go download this and use it today. There are people that have integrated this into their devices and so on. Just take your existing 3-tier backend infrastructure, like you have a web tier, an application tier, and a database tier. And you say to the web tier, you're not really a web tier, you're more like a talk to the devices tier. You have to change it a little bit, right? Because the traffic patterns are different. And instead of having 100,000 people connected to your web server, maybe you have 10 million devices, right? But they're not quite as chatty as people are. So it's a little bit different, but it's not hugely different. It's not that hard to change it. And then you need to make sure you can talk to something on the edge, and that something speaks a language interoperability protocol, something that you're familiar with, REST, like XML, maybe something a little bit more space efficient. There are some special protocols used in this space, like MQTT, CoAP, and so on and so forth. But it's really just, all this is just the ways to get the data from the edge device to the backend. Okay, so it's just about the data. And of course, again, common security, development, management. In terms of kind of types of devices, well, embedded, you may think it's really small. Some of these embedded devices are very large. The largest place I know where we have Java integrated is Airbus A380, and kind of by a far shot would you ever be able to say that's something small compared to what, like Jupyter? And of course you have Java in cars, printers, ATMs, vending machines, kiosks, you name it, right? And then you kind of have the medium-sized and you have the small-sized, okay? If you want to generalize, the way we look at it is there are really two high-level classes of devices. You have the edge devices and you have the gateways. Okay, an edge device is typically very small, typically run on battery power. It can be connected directly to backend if you have something like a wireless module, which is nice for something like a vending machine or a car, or it can be connected through a gateway. If you have a home automation solution and you have a smart meter, there's really no point in that smart meter having its own 3G modem. It can talk to a gateway, and that can be your connection to the backend, hence the name gateway. So this is kind of the generic architecture that we're looking at, and of course we have our own products for this space. And in general, you can say that these things can run Java SE and these things can run Java ME. Okay, and whether you should choose ME or SE, you shouldn't really worry about the names here. ME stands for micro edition. So if it's small and really power sensitive, you would run micro edition. And it's slightly larger, you would run standard edition. And of course, with ME, you get fewer APIs and some fewer capabilities. Well, that's the price you pay for having lower power and less memory. So less than 1 meg here and 10 megs and up here, give or take. Okay. All right, so these are kind of products. These products are available for download today if you want to play around with them. If you have a Raspberry Pi, you can go download Java Embedded Suite and run it on your Raspberry Pi. I had a journalist that did that in the US. It took him 10 minutes to create the first gateway application, including downloading it. I was quite happy with that article. I didn't pay him for it. I should have given a Raspberry Pi, I guess. He was cheaper than you are. You took a Pi just to come listening to me. All right, here's a use case. I'm going to quickly walk through a few possible use cases for this. So I talked about the greatness of technology, right? But what I really want to is to give you guys a seed in, like, how can I take this interesting thing and, like, where can I apply it? What can I do with this? So I'm not going to tell you customer success stories. I'm just going to go through areas where you could technically deploy this technology. Smart grids, smart meters is one. So this is the concept of having an electricity distribution network all the way into your house, which just is a little bit smart about how and when it uses energy. This is a light example I made. There's a small company I'm going to meet later this afternoon that sold some kind of embedded module to a town in Norway, where they basically turn down the street lighting if no one's around. So if no car is around, you turn down the level of street lighting, car comes, get it up, a pedestrian walks by, make it even stronger. And I haven't seen the numbers, but I wouldn't be surprised if you can cut the energy consumption by half by doing that. So I actually think that smart grid, smart energy has the potential of saving more energy than all the kind of green energy initiatives in the world. Okay? Wouldn't you like to help save the world? There we go. So what about healthcare? Wouldn't you like to help save your grandmother? So now you tell me honestly, do you think it's more important to save your grandmother or the world? That was a bit cynic, wasn't it? Can we save both? Yes, we can. Java will save your grandmother. Okay, very good. So healthcare, well, this is another one of those. It's very expensive to have people in hospitals, and increasingly expensive to have people in hospitals. So enabling people to be in their homes and kind of treat themselves or be kind of watched over by relatives is a great thing. But you would still like to be able to monitor them, especially if you're doing things like aftercare or if they have a chronic disease of some kind. So can you put a sensor on them they can carry around, and then if something happens, it sends an alarm to the doctor? Of course you can. This is actually starting to appear. There are some examples of this. It's not really widespread yet, and it's not widespread because it's still a bit complicated and there are some regulatory problems to get around. But technically, these problems can be solved. Right? So I know there are solutions in the US, I don't know if they are in the Europe, where if you have an old person, they carry an accelerometer on them, and if they fall and don't get up within a certain period of time, the ambulance gets alerted. And there are like a number of kind of success stories, if you will, in the press where people have actually, their lives have been spared because of this. So give that some thought. So we're not talking 1984 again. We're talking simple applications that really help us with our lives. Okay, saving energy, saving your own grandmother. Right? It's not more complicated than that. Quickly go through a few areas where you can see city automation is one. So you can, of course, use these embedded devices connected to a network to kind of better manage your city. And before anyone kind of comes up with a great idea to break into a Java-enabled kind of traffic light control system, let me tell you this. These things don't run browsers and applets. So we don't have security issues here. Okay? Sorry about that. I know you would have loved that, but it's not the case. All right. Industrial automation, another great example. Industrial automation has been in place for some time, but it's been fairly complicated with like specialized industrial PCs. It's becoming very, very simple these days and very cheap. And this is one of the areas where we sell a lot into. It a bit more isolated, probably. This is not so much the Internet of Things that it's like your intranet of things, if you will, inside of your company. But it's still a very important area where you can help improve the quality of the development you're doing. Transportation and telemetry is another area. Oracle, based on the old Sunspot technology that some of you may have heard about, built a pretty cool prototype where we put a Sunspot with a bunch of sensors and 3G and Iridium antenna, the satellite communication network, and put it on a shipping container. And it would monitoring things like what's the temperature, what's the humidity, have you had a shock? I mean, did someone pull it up on a container crane and then drop it? Where exactly in the world is it right now? Did someone open the container and steal something from it? Okay. So basically monitor this in near real time so that when you're shipping something from like place A to B, in this case across the Atlantic, did something happen in the meantime? Say I'm shipping some medical supplies. Can I guarantee that there was no environmental condition during the transit that would adversely impact the quality of my medication? Okay? Simple stuff. So lots of good places where you can use this type of technology, and developing software for this, assuming you have Java in place, is not hard. So you can take your skills and do it. So I talked about some kind of random things. What I would like to do is to bring someone up on stage that has more experience directly with what you would use this for, and give us at least a couple of really interesting examples. So Axel Hansman from Gemalto. People, come on. Hi, Axel.
Hello, Henrik.
So, Axel, can you just tell us a little bit about Gemalto? Because my guess is that maybe not all people here know what you're doing. So you have to click forward. There you go. Don't ask me why.
Not Java.
It's PowerPoint.
Yeah, so I guess a number of you, most of you will have heard of Gemalto. Gemalto being a leader in digital security, delivering especially smart cards, billions of smart cards for all sorts of applications, in particular SIM cards. So many of you will probably have either a SIM card or a banking card in your wallet or your mobile phone. And about 2 years ago, Gemalto, well, it's going on 3 years soon, Gemalto bought a company called Centurion. We started making wireless modules in 1994. And a wireless module, quite simply said, is something that packages cellular connectivity, the type of thing that you know from a mobile phone. I've got one as well. So something like that. Yeah, it's more like this. Packages all the technology of a mobile phone into a simple and ready-to-use form factor for all these applications that Henrik was mentioning. And like I said, we've been doing this for more than, going on 20 years soon. And we've got more than 50 million of these devices that our customers have put out into the field. So there's quite a few people that have already earned $1 million.
So you used Java in your modules for 20 years?
No, not for 20 years, but it's our 10-year anniversary. We started implementing Java for the first time in 2003. So this year is the 10-year anniversary. And if you think about what Henrik just said, then it's all about the smart city, and we've got a tremendous amount of applications. Like we've got the smart metering applications, and we've got healthcare applications already also running on Java. There's another very interesting sort of smart city type of application, Deutsche Bahn's using a Java module in the remote train stations, where they're using our cellular module to connect the remote train stations where it doesn't make sense to put bandwidth out there, connect these train stations. And they're driving the display that tells their customers when the trains are arriving. And they're using the audio functionality in our modules to drive the announcements out in these remote stations.
But you have one use case you told me about, which is like really fun. Is that the one on the next slide here?
Yeah, you click that.
You just have to tell me about it, because it's like, this is my favorite
yeah, so
ever.
I said, I mean, we actually, the Gemalto is the Internet of Things, or rather actually what Henrik referred to as the M2M company. But I couldn't believe this when a customer of ours started connecting trees. He wanted to track trees. And now you understand why it makes my marketing job so difficult, because how do you find a customer that starts tracking trees? And
Internet of trees.
but it's cool because we'll earn more than $1 million once he puts them in every tree. But no, so the problem is in the Amazon forest there's a lot of trees, but some of them get lost, they get stolen. There's a lot of illegal deforestation, and which is something that obviously the Brazilian government worries about. IBAMA is an agency that was put up to try and solve this problem of illegal deforestation. They're doing a lot of things, and one of the things that they've done is they've put basically our technology into a tree to track a tree when it gets stolen. And so when it passes a base station, it sends a signal, and with the location, and IBAMA, these agents come in and try and locate their tree to find the people that were stealing trees. It's a customer of ours called Cargo Track, and this little box like that that he puts into, that they've given IBAMA to put in their trees. Originally what they actually use that for is to track televisions. So they manufacture in the Amazon forest, and sometime every now and then a truckload of TV screens gets lost on the way from the factory to the harbor. So similar to tree tracking, they were tracking their TV screens, which seems more natural to me.
Internet of TVs.
Trees. Yeah, so
anyway, this use case is just really cool. I understand this is actually not a Java-based module you're using yet.
No, we're unfortunately not using Java in the trees yet, but we're using them in the displays and the train stations and healthcare applications and smart metering.
So we have to fix that, so next year we can come back and help say that Java saves the rainforest, which will be kind of nice. But I think it's absolutely amazing. I'm sorry, I know I'm a bit enthusiastic here, so it's kind of like a TV shop thing, that you can make these things so cheap that you can literally put it in a treetop, right, and then catch loggers. And if nothing else, I think that gives you a sense of how diverse the use cases for this technology is.
Yeah, it's actually the same company that's putting them into the TV screens. That's disposable, so they use it simply for the purpose of tracking the TV from the factory to the harbor. And then the customer just sits in one of those boxes. The customer doesn't know what to do with it when he unpacks the TV screen and just throws it away. Yep. So like I've said, this is basically packs the technology of a mobile phone into a small, ready-to-use form factor for industrial applications. So you can use these in smart meters that should be out in the field for 15 years, say. It's got the relevant applications and approvals so that you can use them in the US, you can use it in Europe, you use it for almost any operator network, provided in this case that it's either 2G or 3G. And it comes with a wide range of interfaces, and there's a lot of benefits of doing this. So like Henrik pointed out, it'll help you at the end of the day. You can get rid of the microcontroller. It makes your bill of materials lower. It makes it more easy and efficient to develop applications because you've got a whole range of developers. You've got maybe functions, code that you can reuse. Actually, last week we had a customer at a conference who was telling us how great this technology is, and he'd been using the same code that he programmed in 2005 on the 4th generation of our modules, and his application still doing exactly the same thing, but he developed this 10 years ago, or 7 years ago, with slight updates, and it's still running.
That was a smart meter use case, right?
That was a smart meter use case in Turkey, yes.
I love that. So the guy, when he started doing this, everyone laughed at him because they thought Java was ridiculous for small things. But now he's laughing all the way to the bank because no one can keep up with his pace of development. So he's got 60% of the market or something. Yeah. Go Java.
So anyway, if you want to come find out more about what we do with these things, how it works, an example, we've just got a little demo that we brought along. You can come and listen to me and a colleague from the local office in Stockholm doing a session at 1 o'clock called Benefits of Java to the Embedded Ecosystem.
Excellent. Thank you, Axel.
Thanks, Henrik.
People. The guy that saves the Amazon rainforest. All right, I'm pretty much done here, so I'm going to hand over to my colleague Sharath shortly. Of course, we're not standing still. We're doing a whole bunch of stuff, carrying the technology forward. So we're building and selling Java for these things. So unlike Java for desktops, we actually charge money. And for the record, Java license for this little thing here, if you buy it from Oracle, the first unit is 60 cents, so it's not particularly expensive. Buy it in bulk, I'll give you a discount. Okay? Or you can buy it from Axel, it's already included. So we're carrying the technology forward, and the entire idea of the development we're doing is to basically make sure that the core platform, whether it's Java ME or Java SE, and with Java SE we also have this Java Embedded Suite product. The reason why we feel we need that is Java SE itself doesn't actually have the concept of an application container, so you need to have an application container so you can manage it. All right, so we're carrying the specifications forward, we're carrying our products forward, and of course we're carrying the ecosystem forward. So we have a bunch of products and specifications today. Once we ship 8, the entire kind of 8 version, so SE8, JDK8, we'll have Java SE Embedded 8, which is a footprint optimized version of JDK8, more or less. We'll have Java Embedded Suite 8, which is a bunch of goodies. You can hear more about that in later presentations. NetBeans will have support for embedded. Of course, you can use another IDE, but I mean, we roll our own, so that when we ship a product, at least we know we have support. Java ME, huge step forward when we ship 8. We're bringing Java ME up to the same language level and the same API level as SE. So you may not be aware, but if the Java we use for feature phones today is actually stuck on Java version 1.2. So we're bringing all the language features in from SE to ME. So it'll be a lot closer how you program ME and SE moving forward. And tooling. And of course, after that, we expect to keep to the same kind of two-year schedule that we have for SE. So there'll be a new major release approximately every 2 years. All right, so good stuff. So why should you use Java? Well, because it's great, okay? And I guess that's pretty much it. So what I want to do now is to hand over to my colleague Sharath, who will talk a little bit about how you can get involved.
Thank you, Henrik.
Give me an applause, people. Sharath Chander.
So let's make sure
the guy behind Java 1.
The gentleman behind Java 1, right. So good morning, everyone. Thank you for having me. This is now my second time at JFocus, and I'm actually ecstatic that the JFocus team has brought this inaugural Java JFocus embedded event here to Sweden. This is an industry, as Henrik has mentioned, that is growing. We all know that the embedded market isn't anything new, right? Embedded programming has been going on for a very long time. For many of you who are C or low-level C developers, you already realize that, because that's what primarily the embedded market has been involved with from a language perspective. But now that technology has changed and the evolution has caught up, Java does have a place. Before I begin, I just want to take a quick poll. How many students are there in the audience? How many students? If you could raise your hand high, if you're a student. It's actually a trick question. We're all students. My father told me that learning is a lifetime endeavor. So whether we've graduated from college or a university and moved into the professional workspace, our noble profession of development always changes. That's what makes our profession so unique. It constantly evolves. And this new embedded market, whether you call it embedded or M2M or the Internet of Things or the Internet of Trees or the Internet of TV, it is a new opportunity for all of us to enrich our career. Just think about it. The sheer number of devices that will be in the marketplace in the next 10, 15, 20 years will eclipse the number of human beings on this planet 10, 20, 30-fold. And as software developers, that's a huge opportunity, not just to monetize our work, but also create new ideas and new passion within all of us. I remember back in my days when I was just learning low-level programming, and I said, is this what I'm going to do the rest of my life? And once I got involved in Java, and understanding Java programming is, there's new ways to look at how we can utilize this technology in the things we do. So what we do today will definitely be different 5 years from now, 10 years from now. And we as contributors and stewards, not just Oracle, but all of us, can ensure that evolution continues forward. So I say to all of you, you are all students. We must continue our learning. We must continue to foster passion, because for Java to have a place in this market isn't about just Oracle's contributions. It's what you also make towards it. We're so lucky to have a technology that has your participation. Your innovation makes that possible. And only by sharing it collectively with all of us, whether it's through your academia efforts, whether it's through a Java user group, whether it's through some other mechanism or forum, the only way we stimulate greater innovation and passion is by us all sharing that. So let me just make sure I have this correct. So click to the next slide. Right? So in terms of learning, you're all students, and we at Oracle understand that. And we have assets in place through our Oracle Technology Network where you can go and learn not just about Java, but specifically about Java Embedded. We have assets in place at OTN. We ask that you become a member. It is free. You can pull up a lot of learning assets, code samples, and information of that type from this program. But what's more important about just learning is using and sharing. So one of our new assets that we have, which is again also free, is the Java Magazine. It is a publication for developers by developers. It is completely technical. We're always asking you, the community, to contribute your technical articles to it. It's not about what we just do. It's about sharing your innovation so it can inspire other developers to do and follow in your footsteps. And when it comes to embedded, once you start picking up these devices, it's hard to let go. It's something that I love to play with. I know many of you, as soon as you grab onto it, you now have all your Raspberry Pis, I'm assuming. Do all of you have your Raspberry Pis? Yes? By the way, if you visit the Oracle booth and want another one, we're doing raffles today and tomorrow. So if one isn't enough, come visit us for the drawing. We'll be doing multiple drawings. But once you pick this up, it just inspires you to think of different ways I can start building applications to do very interesting things, right? Whether it's saving a tree, or doing something more meaningful. For example, I have a colleague who works for the National Oceanic Institution in the United States. His passion is saving whales. And so his idea is to put these monitors and trackers to ensure there's no illegal harvesting of sea life. So it doesn't just have to be something about putting money in your pocket. It could have a social benefit for humankind as well. So think about that. Share those types of articles with us. Get it published in Java Magazine, have it shared with the community, and continue that evolution of sharing knowledge across the entire developer ecosystem. The last asset that I would like for you to think about is, as you start playing with these gadgets, it's one thing about me knowing what I want to do or what I can't do, but then having other developers contribute to those projects. Consider hosting a project or an idea or a concept on java.net and have that shared and federated with all of the members within that ecosystem. Now, we've stood up a portal specifically just for Java Embedded at javaembeddedcommunity.com. It allows you, as an aggregation point, to have Twitter feeds, blogs, technical articles, technical resources specifically just on embedded. And if you want your project or your Twitter handle or your blog or other assets you've created to show up there, just ping me. DM me on Twitter. Stop off and meet me in the booth, grab my card, whatever it is. Our goal at Oracle isn't just to be a steward of Java, it's also to expose your technical abilities for other developers to have the same passion as you. And I think that's the big takeaway, not just this topic about Java Embedded, but overall at JFocus is we're here to learn, but we're also here to share. So after this conference, think about all of the different ways you can share your passion, your innovation, your questions with your peers so we can all have this continued community effort around Java. So with that, I want to save you some time, say thank you, and hand it back over to Henrik, or...
Thank you, Sharat.
Thank you.
Can we do a bit of Q&A?
Yeah. Are you all right? Yeah?
Why don't you stay on stage? So I actually think we're 5 minutes ahead of schedule here.
Yep. So can we take some questions? I'll come and bring the mic if you have a question. Any question? Okay, cool.
There we go.
Yep.
And that guy's name is Don, and he needs to get a shave. Hey,
Hi.
Don.
I got a question on the network connectivity. When I look at small things spread over, for example, a traffic jam, I see that there might be interesting ways for network to form. So instead of having a centralized server,
Yep.
Everything could talk to each other, not via the server, but peer-to-peer.
Right.
So how do you look for the future of peer-to-peer networks and applications?
Yeah, so what you're talking is something which in the industry is called mesh networking, where basically a set of devices, it's kind of like if anyone has played around with the Sonos system, a set of devices basically, when you start them up, they negotiate the network within each other and form a mesh. And then any two endpoints in this network can talk to each other through this mesh. And that's a technology that it exists already in many real-time embedded operating systems. We're actually looking at bringing it into Java to have it be enabled as part of the standard software stack. And the most likely specification that we would use would be ZigBee, which is used for instance, home automation today. So yes, mesh networking is really interesting. Not so much because you get the ad hoc capabilities, but rather because you can do networking with extremely low power. Yep, I hope that answers the question.
Other questions? Just raise your hand. Or comments. It doesn't have to be a question.
Yeah, there we go. You guys are nuts.
I was wondering about the power supply for these tiny small devices. How do you solve that problem if it's in a tree? I mean, you can't.
How do you solve the problem in tree? Actually, you know what? I know the answer. Why don't I let Axel answer that? Because he's the expert on these devices. How long can you run on battery power on one of these?
Well, it really depends on your application. We've got algorithms. You can put the cellular component to sleep, so that reduces power consumption. You can wake up the application every now and then to just check your sensors or whatever. I mean, you get other applications that have a much higher power requirement because they need to run all the time. So it really depends on the use case. And I mean, for these trees, I think the module runs about a year or so without additional power. And battery is probably then one of the expensive components in your solution. That's something that you would always want to look at, try and optimize, and make fit to your solution. Yeah,
and also what you may have seen if you walk around the street, at least in where we live in California, is if you have devices like this in street lights, it's fairly common for them to be battery powered, but also have a small local solar cell. So they don't run indefinitely, but they run for a very long time because they charge the battery on solar during the day, and then they run on battery during night.
It also depends on, for example, whether it has a display. So many of our applications don't have a display. Yeah. And then, if a display requires backlights or something like that, that chews a lot of power. Yeah. But I guess the key of the answer here is they're extremely low power. And if you have an application that doesn't necessarily need to run 24/7, if by putting it in sleep mode most of the time, you can run for an extremely long period of time on a battery.
Yep, so a lot of solutions are also relying on solar power where energy consumption is a problem. Does anyone know who James Gosling is? Anyone? Right? So his new company, Endeavor Liquid Robotics, he has these autonomous sea vessels that you just launch at a dock. It finds its way based on geo-coordinates to some point in the ocean with some number of scientific sensors with embedded technology on the autonomous device itself. And it's just running on solar power, gathering whatever scientific data the researchers have, and then it just sails back to the dock. And it's relying on recyclable energy. So it's something you need to think about as far as how can I utilize this, whether it's through lithium, through solar, through some other mechanism. It really is all about the use case that you're doing, and then you have to apply and optimize. By the way, he is here, correct? He's coming to speak.
I think he's streamed from the US.
He's streaming, right?
Yep.
Okay.
Unfortunately.
Yeah, what I forgot, we've got a booth upstairs. So if you still have further technical questions, you can also come and ask us there during the breaks.
All right. Any more questions before we wrap up? I think we have time for one more, maybe.
What?
You said something briefly about license costs.
Yes.
For the embedded. Could you just go over that again, please?
Sure. So license costs for embedded Java. So Java is free for developers and for general purpose. Java has always been has a royalty license for embedded devices. and for phones and so on and so forth. So Nokia is one of our large licensees, to take one example. And basically that type of revenue for Oracle funds the Java development. So for embedded, what we've done is we've cut the prices quite a bit in order to encourage very wide adoption. And as I said, depending on the type of device, you pay a license. The price list is not public yet. I hope we'll be able to make it public. Oracle's price lists are in general public, so you can find them. But for entry-level chips like this, again, the list price of the first units is 60 cents, which is, I don't know what this particular thing costs, but like a microcontroller, maybe $5 or something, right? So it's maybe 10% of the cost of the hardware. And if you buy large quantities of them, of course, there's a pretty nice volume discount. So it's not a lot of money, but you know what they say, like, it's free. Yeah, well, we'll make up for it in volume. Okay. So there is a license price attached to it. But if you just want to go play with it, you can just go download it for free. We don't charge developers. Okay? No more questions? All right. Thank you very much. Thanks for coming here.